Hey everybody, so I want to make this video because I read this article and it is pretty insane to me overall. Like, I don't know how else to put it, etc. And this exists, it's going to exist, and I think most people don't understand how and why these things function, and so it's important to do that, right? So this article is called World's First AI Designed Viruses, A Step Towards AI Generated Life. And in this instance, they create a bacteriophage to kill bacteria. So it's they use it in a very good instance for this, right? For antibiotic resistance, and the AI creates essentially its own virus to kill the host bacteria, right? And then so within this overall, like they're I mean, I don't know, like, why it needs to be spelled out that this is bad overall, right? Like, but it's going to happen. It is happening. Like, this is the world, right? Like just saying that, like, oh, this is bad, rah rah rah. It doesn't do anything around these things, right? Like it's going to. The research will continue. People will continue along these lines. It's what is. Far more important to me is for people to understand these things, right? To me, like, the biggest thing that people ask is, like, can an AI do, like, solve problem X, solve problem Y? Like, can it create its own, can it create a virus? Like, all of those things, right? And it's all of those things point to the fact that a majority of the population doesn't understand how these models actually, like, think or reason, right? And then whether or not you want to actually classify that as thinking or reasoning is fine. That's a completely different debate, right? But so this process that occurs within the models, like, most people don't understand that process, right? And then so that process can be broken down. It is, like, solved at this point as to how that process occurs on a broad level, right? There's still some black box elements to it, but on the broadest level, like, I can fully explain this out to you. And then so all of this comes down to the concept of a horizon window, right? And then so I'm going to focus all of this discussion around this concept of a horizon window. And then so AI models don't just know things, right? They operate by processing data step by step within clear limits. So to understand this, we're going to look at three concepts and three kind of ideas that are grouped together within this. The first one is a horizon window. And horizon window is just very simplistically at its core, how much the model can see at once. Like, its ability, like its world, right? Its distance of its universe. Planning versus executing. The difference between thinking ahead and actually doing the next step. For humans, this is pretty intuitive. For an AI model, this is a vast difference that plays heavy within this entire equation. And then within an horizon window, you have a horizon distance, which is how far the model can reliably extend its plan. So horizon window is the size of its universe. Horizon distance is, like, how many steps it can plan within that size of that universe. So let's dive deeper into these concepts. The horizon window, the immediate workspace. So the horizon window is the space in which AI models actually act. Think of it like the desk that's in front of me. Only the information placed on the desk is visible to the AI at any given moment. Anything not on the desk has to be forgotten, summarized, or reintroduced later. When the AI executes an action, like writing a word, solving part of a math problem, or suggesting a step, it does so only using what fits inside of the current horizon window. And, like, within this, I think the biggest question that people have within this is, like, what affects the size of that context window or that horizon window. And then this is where, like, model size and scaling comes into play, right? Like, so the size of the model very directly does increase the size of the horizon window, like, flat out. That's been proven. There's no, and then what, like, kind of plays into, like, people's, like, sci-fi fantasies around these things is that there's been no proven, like, hard limit to the amount that this horizon window could scale. Like, so I mean, but like you're getting into like very extreme situations within there. There's no hard window theoretically that you couldn't attach like a AI model to a Dyson sphere and then be able to get that amount of energy and then that amount of horizon window size. And then an AI model attached to a Dyson sphere would obviously have a far bigger horizon window than an AI model attached to your iPhone, for example. And then secondarily, like moving back into like kind of like reality within these things, the second concept of this is planning versus executing, which is two different modes. So planning is when the AI outlines a possible path forward, imagining what might happen if it takes certain steps. This is like sketching out a strategy in your head. Executing is when the AI actually commits to the next action, writing the next word, moving to the next chess move, or outputting the next calculation. Planning happens across the horizon distance. The AI can simulate several steps ahead in its mind's eye. Execution happens only within the horizon window. The AI produces real outputs based on what's in front of it right now. As an example, in chess, planning is saying if I move my knight here, then they move their bishop there. Execution is actually placing the knight on the board. The AI can only execute one move at a time, even if it's planned several in advance. And this isn't like so. When it comes to like the problems of tokenization and all of that, that's my biggest problem overall within it, right? Is that tokenization as a concept overall severely limits the horizon window. And it's a very big limitation of the horizon window overall, because essentially what it leads to this, right? The AI can only execute one move at a time, even if planned several in advance. And the only reason why this last statement and this last sentence is true within AI models is because of tokenization. So when models, like before reinforcement learning, the entire horizon window of a model was the next token, plain and simple, right? And then and within reinforcement learning, and chain of thought reasoning, etc. These things are very specifically designed to play within, to strengthen, to broaden, etc. that horizon window within the models. Horizon window is very simplistically, like in its most simplistic terms that I can put it within this, the amount of planning steps that a model can make before it fails, right? And then so every amount of problem, breaking this in the most simplistic terms possible here at this point, every single model or problem that exists has a number of planning steps that are associated with it. If it's a simple arithmetic problem, what is 2 plus 2? There's like 2 steps, 2 planning steps that are associated to get you to the answer of 4, right? And then so that's a very simple problem. What is the meaning of the universe? I don't know. My horizon window isn't large enough to produce enough planning steps to be able to execute on any sort of possibility of a solution for that, right? But if my horizon window were big enough, if my brain were hooked to like a Dyson sphere, I could maybe do that, right? Because that might produce, then we're getting into the realm of possibility of producing an answer to that particular question, because there would possibly be enough planning steps within that particular horizon window. It actually becomes like realistic that a manifold could execute and be able to process on that. And then but that secondary process of executing is important within this, right? So this is super, overall we have this process of planning and executing, and then these are very much two very different concepts, right? And it's different concepts for humans as well, but it's magnified for AI. And then so for planning, humans go through this, right? If I can plan out a situation in my head, and I'm going to go through all of the instances that are going to occur, but then when I execute on it, there are a lot of things could fail and lead to failures within that execution, right? And then the further that execution deviates from my planning, the more I will have a higher failure rate overall, right? And that's just kind of how it breaks down. And then within these concepts of planning and executing, AI doesn't operate at all like a human when it comes to these things, right? I think the most important aspect to understand within this is that when it comes to this planning aspect, this is where like the AI models are like superhuman. Like they're off the charts planner. Like an AI model is going to obliterate you off the charts when it comes to planning. AI model is going to, generally speaking, lose to a little baby when it comes to executing. And then so that's the big difference and the gulf within that, right? Like models are brittle when it comes to executing. Like this was a question and a problem within this because models are generally brittle overall when it comes to generalization, right? And then so it was a question, where exactly does that brittleness come from? The brittleness comes from here and not from here. And that's been proven out. And then so diving deeper into kind of the third concept within this of the horizon distance, right? The limit of reliable planning. And then so the horizon distance defines how many steps ahead an AI can plan before its predictions fall apart. So if you have a short horizon distance, AI can only see a few steps ahead clearly. If you have a longer horizon distance, more steps can be chained reliably, but there's always a limit. Like it's just built in, right? And then so like if you didn't have a limit within this, you would get a calculator. And then so crucially, horizon distance affects planning, not execution. Execution is always one step at a time, but the quality of each step depends on where the plan leading up to it is still accurate. So how does all of this interact together? One, the AI plans ahead within its horizon distance, imagining multiple possible futures. Two, it chooses an immediate next action or an execution step, but can only do so based on what is currently available inside of its horizon window. Three, as each action is executed, the plan must be adjusted because the real world never unfolds exactly as imagined. This creates a cycle: plan, execute, update, and replan. So, the bottom line within this is that within its horizon window, in this instance, when a model goes to execute something, is generally speaking one sample of its probability distribution, right? There's a video that I made earlier where I talked about this yesterday, where I talked about the method that Meta produced with regards towards like the debate feature of the models, and then within that, essentially, and breaking that down, that's directly applicable to how this works within the execution, right? Because if the model gets more access to more probability distributions, that increases its horizon distance and then therefore increases its ability to execute overall. So why people get confused around these things? Most people imagine AI as an all-seeing, all-knowing system, but in reality, it can't execute beyond its horizon window. It's like writing one word at a time without seeing the whole book. Its plans are limited by horizon distance, so if it tries to plan too far, errors multiply, and then execution is always immediate and local. The AI doesn't leap to the final solution, it steps through one move at a time. As a final thought around this general horizon window concept, the power of AI comes from chaining together many small executions, many small steps together, chaining steps together, right? Chain of thought, reasoning, etc. That's what that whole entire process is, guided by limited planning. The horizon window defines what it can act on right now, while the horizon distance defines how far ahead it can imagine. Understanding these two boundaries explains both AI's impressive capabilities on one side and then its natural limits on the other, right? Like why does it why is it superhuman in some aspects and worse than like a little baby in other aspects, right? And that's exactly why, because of these particular concepts, and there's lots of other reasons, right? But the big broad aspect of it is this. And then so I want to break this down further and apply this directly to problem solving as most people ask it, right? And I think this is a good aspect and a good area to point to as to problems that people generally pose around these things. Like, can AI models solve a problem like this? And then it all comes down to that, these concepts playing off of each other. And then so I want to dive deeper into like how exactly that works within this, right? So AI is powerful, but it has important built-in limits. Two key ideas help explain these limits, which are horizon window and horizon distance. So horizon window is, again, how far the AI can see. So think of horizon window like the length of a short-term memory. An AI model doesn't read and remember everything at once. It looks at a window of text or data and works within that boundary. As an example, imagine you're trying to solve a puzzle, but you can only look at 10 pieces at a time. That 10-piece view is your horizon window. And then so every 10 pieces, you can move a new 10 pieces, right? So you have a sliding horizon window in that instance. And that's exactly how the models operate within this. Their horizon window is sliding. So for AI, this means it can only consider a certain amount of context, like words in a conversation or data in a file at once. If the text is too long, older parts just simply fall out of view. And like a lot of this is important, right? Because a lot of people just try to like chunk in huge amounts of data into the model, but you're just like that data is going to fall off. The model performance is going to dip because that horizon window is just filled up with all this data, etc. Right? And then so reasons why those types of things just aren't like a big catch-all are understanding all of this, right? Two is that horizon distance is again how far AI can think ahead. So horizon distance is about how many steps into the future AI can reliably plan or predict before its accuracy falls apart. As an example, going to that chess example, a chess player can plan 2 to 3 moves ahead easily. Planning 20 moves ahead is much harder. So the distance of reliable foresight is the horizon distance. For AI, this shows up in areas like long reasoning chains, writing long stories, or making multi-step scientific predictions. Beyond a certain distance, errors start to pile up. And then that's the bottom line within this, right, is that once you start getting and your horizon distance becomes larger and larger, which is what a lot of people do when they try to just like rag and dump information into these models, right? And they're just like, well, like the context window is like 1 million tokens, but you're filling up the horizon window, right? And then you're increasing the horizon distance by doing that. And then so you're increasing, and that's why you're getting your errors piling up. So why people ask extreme questions around these things, like when people hear about AI, they often ask things like, could AI design a biological virus, or could AI solve the universe? These questions are really about horizon distance. Designing something like a virus or explaining the universe requires, one, vast long-term reasoning beyond current horizon distances, and then two, access to massive precise data beyond the AI's horizon window, and then three, real-world experimentation, which AI has none of on its own, right? So right now, AI is more like a sharp flashlight. It's powerful in the beam that it casts, but the beam can only reach so far. And that's like the bottom line within it, right? It's like if you frame your question, can the models solve the problems of the universe? No. Like, can the models just create like a general virus out of out of all viruses in existence? Currently, no, because the horizon window is too large, right? Or it's too large of a problem for the horizon window. But can AI models design a specific bacteriophage that is designed against a specific antibiotic-resistant strain of bacteria in order to combat that? And then as we can see, the real answer to that is yes, right? I mean, very clearly, here's the article for it. And then so common misconceptions. Myth: AI remembers everything. The reality of this is that it only remembers what fits inside of its horizon window. Myth: AI can plan unlimited steps ahead. Reality of this is that it gets unreliable past its horizon distance. And then myth: AI can act in the world on its own. Reality: without human input, tools, or experiments, it's limited to patterns and data. Like this last one, I'll just touch on it, right? I think humans have this concept and this internal self-desire, right? Something internal within humans that are is like a go mechanism, like a self-go, whereas AI lacks this overall. And then so this lacking of this overall is why I don't worry about like those sci-fi experiments as long as we avoid that. But again, because we're living in a world where you can do anything with an AI, that becomes a possibility of being able to do that. But so educating and yourself and understanding these things are like the only hedge that we have against it, which is here we are. So why this matters. Understanding horizon limits separates science fiction from reality. Practical AI is writing essays, analyzing data, helping with code, and summarizing documents. Beyond the horizon window for now is creating entirely new biology, solving fundamental physics, and then running independent civilizations. AI is expanding its horizons over time, larger windows, better foresight, but there will always be some limit, just like how humans can't see beyond the Earth's horizon without tools. As a final thought, AI's horizon window tells us how much it can handle at once, and its horizon distance tells us how far it can think ahead. Both of these are built-in limits. When people ask extreme sci-fi questions, the answer usually comes back to these two concepts: the horizon of what AI can see and the horizon of what AI can imagine. And then so, to me, overall, this is both comforting and frightening overall, right? Because it's comforting because there are limits and there will always be built-in limits within these things, but then it's frightening because the limits are less and less bounding the more determined a person is, right? That's like, I mean, that's kind of how it actually works out, right? Like if a person is determined to hone in, like I'm like, this one problem is going to be like the only problem that this AI model is going to solve ever in its life, like they're going to be very successful at that. And then what exactly they choose to be very successful at that is a lot broader and wider overall than people think about or give it credit for, right? Like people are very creative overall. And then so whatever you can solve, you can come up with a problem as long as the steps to solve that problem are limited enough, and you can limit the number of steps by limiting the problem itself. Again, like what is like creating a model that will create any virus is very hard, right? Because that's so like millions, bajillions of steps to be able to create any virus. But if I say I want it to create a model that will create virus A with very specifically to counteract bacteria B, that's like that narrows the number of steps involved in that equation from millions and billions down to thousands, potentially hundreds, right? And then so then like you start getting like that's a realistic horizon window to build out, right? And then that could be for any of these problems, right? Like I think like that's the biggest problem that overall like everyone doesn't understand within these, right? Like can you make an AI model that would be like the ultimate marketer? Like no, like because it's too many steps, right? Like the ultimate marketer is like millions or bajillions of steps, but like can you make an AI that will like very specifically focus on this like band and narrow like audience of leads, and then increase the performance of that, like, and the benchmark of that 1,000,000%, right? Because as long as it's doing that, like it's focusing on that, the horizon steps are in the tens or the hundreds. And then so like, yeah, I can guarantee that a model will be able to do that, right? Because I know, and I can do that quick calculation on the fly within that horizon window, as long as the problem is framed as in that narrow capacity, right? And then that's like, so it often, like, to me, it often seems like people will like think that your answers are very like nebulous when it comes to these things, right? Like you'll give an answer and it's like a surprise yes out of nowhere, and then they'll ask another question, it's a surprise no out of nowhere. It's like what the heck is the difference between this and that? And it's all this, right? And then so I can't break it down more simplistically than that overall. I'll leave a link to this article here as well as this document that I went over, and if you like this type of content, please like and subscribe. Thank you very much.